So there's a lot of talk about climate today. People are concerned about what's going to happen to the climate in the future. And to understand what's going to happen, we need to examine what's happened in the past and understand what's happened in the past so that we can use that to project what might happen in the future. Now, our observations of past climate, of course, through instrumental records are rather limited, the last 100 years or perhaps a bit more. And so there's a limitation about how much information we can extract from that short interval of direct observations. However, there are all sorts of historical records that can take us back further in time. They can be observations of local weather and climate in people's diaries. They can be inferences about local climate and weather from how good the harvests were for a particular crop, and so on. And then if you go back even further in time to prehistoric times, the artworks that ancient peoples left behind in caves or on rocks often illustrate animals that were in that area at the time, and often we recognise that those animals no longer live there today. And so we can infer in many situations that the environment has changed, the climate has changed, just from simple drawings of animals on a rock face or in a cave. To go back further in time, we need to use geological records. And the best geological records for understanding and studying past climate are the sedimentary records that come from the ocean basins and from lakes. Both depositional environments allow sediments to slowly accumulate, and those sediments incorporate animals, plant residues that we can use to reconstruct how climate has changed in the past. As an example, Lake George near Canberra has an excellent record of past vegetation from the pollen grains that are extracted from the sediment. In deep sea sediments, often it's microscopic floating organisms that fall to the seafloor that record past changes in sea surface temperatures, for example, that we can use to reconstruct the past temperature history of the ocean at that site. A major advance in our understanding of past climate on geological timescales has come from our study of ice cores in Greenland and Antarctica in particular. And through those cores, we have access to unique information. The gas bubbles trapped in the ice record the composition of the atmosphere through hundreds of thousands of years, as far back as 800,000 years. The isotopic composition of the ice itself tells us something about temperature changes. So ice cores are a unique and valuable record of past climate change. In conjunction with sedimentary records, we have a very good understanding of how climate has changed through the last 800,000 to almost 1 million years. The trick is, of course, to extract some understanding of what's driving the climate changes. We can reconstruct how the environment has changed, and it varies around the world. Not all places in the world are affected equally by climate changes on a global scale. Yes, global climate is changing. Yes, 20,000 years ago there was a time when ice sheets covered the whole of Canada and much of northern USA. An ice cap the size of Antarctica sat over Canada. That meant, of course, with all that water locked up in ice on land, that sea level was much lower because that ice came from water evaporated from the oceans. And 20,000 years ago, global sea levels were 120 metres to maybe 150 metres lower than the present. That meant you could walk from Melbourne to Tasmania, and Aboriginal people did that. So not just the changing climate, but changing coastlines are a function of that changing climate through variations in sea level change. 20,000 years ago, to continue the example, around Canberra there were virtually no trees. It was a treeless landscape, much like the subalpine country in the upper areas of Kosciuszko National Park today. In Central Australia it was much colder, yes, but it was drier and it was windier. So sand dunes were moving around the landscape, dust was blowing out of the interior of Australia much more commonly than even it is today. So environmental changes were dramatic, associated with the major climate shift that made up what we call the last glaciation, that peaked around about 20,000 years ago. Before that, many cycles of glaciers coming and going around the world, the pattern of so-called ice ages in the last 2.5 million years, which is driven ultimately by variations in the Earth's orbit around the Sun. These are things that we're now coming to grips with to better understand how and why past climate change, which then allows us to project to the future.